LLMs possess remarkable capabilities. They can comprehend and generate human-like text by learning intricate patterns from vast volumes of training data. However, looking under the hood, LLMs are just statistical approximations from text data, which powers their creativity and generalization capabilities. And like any other tool, it's not perfect and has its own challenges and limitations. For example, they are typically black boxes, and they do not know what is going on or how did they arrive at answers or which data sets the answers came from. They all suffer from hallucinations and are typically non-deterministic and cannot provide provenance. Most of the meaning of the text in LLMs are encoded with vectors, which are again opaque numbers, and that prevents from doing traceability and explanation and even statistical inferencing. Trust is a huge issue with non-public data. And also LLMs are actually trained on stale data. However, data management applications need 100% correctness in their production systems. Now let's look at knowledge graphs. For most of you who don't know knowledge graphs are everywhere. Most search engines under the covers are using some form of knowledge graphs, from Satori engine of Bing as well as Google search. Any assistant, any personal assistant you use like Siri and Alexa are also to some extent powered by knowledge graphs. Uber Eats, for example, uses knowledge graphs, and the list goes on. Knowledge graphs help to build relationships between entities, which can help in many other applications and can bring in semantics and context within the data. Knowledge graphs are also successfully used across different domains like life science, finance, energy, publication, connecting and integrating heterogeneous data for knowledge discovery, analysis, and decision making. But again, knowledge graphs also have their own limitations and challenges. They are hard to construct and maintain. They use a vast array of technologies, and the learning curve is typically on the higher side. They're also challenging to handle fast changing data, especially real-time or streaming data, and often require query languages, specialized query languages like Sparkle to arrive at answers. Now, the world we live in is very deterministic, while the world of quantum physics is highly probabilistic. And it's this combination that makes the universe work. Similarly, wouldn't it be great if we could put these two powerful technologies and cross-pollinate and build synergies by taking their limitations and by solving their limitations by taking the strengths from the other? And let's discuss briefly why it makes sense to put these two technologies together in a collaborative partnership and reinforce sort of a feedback loop to help each other. So there are two major buckets of where LLMs and knowledge graphs have their use cases, with one bucket being LLMs that can be enhanced and enriched with knowledge graphs. And then the other part is knowledge graphs enhanced and enriched with LLMs. So the first part, look at how LLMs can be enhanced with knowledge graphs. As we said, LLMs have certain limitations. LLMs trained on general corpus data may not be able to generalize well to specific domains or new knowledge. So LLMs can be boosted with knowledge graphs in the training session, in the training area, where knowledge graphs can elevate the performance of LLMs by offering a more comprehensive context of the data that is getting analyzed. Knowledge graphs are also well known for their symbolic reasoning to generate interpretable results. So knowledge graphs can provide context in the prompts given to LLMs to enrich the accuracy and relevance of the answers coming from LLMs. In the output part, one can leverage the concepts in knowledge graphs to put guardrails around the language model. And this alignment sort of ensures that the model's output remains consistent and logically correct based on your organizational data. Knowledge graphs can also be used to validate the consistency of the responses from LLMs. And thereby, knowledge graphs can enable good amount of risk assessment and empower identification of sensitive information, as well as in highly compliance and regulated industries, as well as ethical issues. The next use case is with knowledge graphs enhanced with LLMs. Knowledge graphs can be enriched and reused with LLMs. As we said earlier, constructing knowledge graphs is a challenging task. And here we can leverage LLMs as an ETL tool to easily bootstrap and build knowledge graphs with ontologies. For example, you can give a set of PDF files and an ontology to an LLM to generate a knowledge graph. Knowledge graphs can also be boosted with textual descriptions of the entities that they represent, as well as LLMs can be used to classify the entities in different clusters. In the retrieval part, knowledge graphs can be boosted with LLMs to generate a query, the complex Sparkle queries, for example. They can be used to summarize even the results that are coming from the queries. And they can also be used to explain the queries and the schemas if they are too complex. Also, one can add embeddings generated from LLMs to do similarity searching within knowledge graphs.